Oh, Lordy, we figured it out. We got it working. Before I go into the reveal of how I actually got it working, can somebody explain why is it exactly after you post a public question about a particular issue, you yourself figure out the problem? How? Why? How does that work? And how can I harness that power? So to recap, I have a Python SDL application running on this little computer, the Libre Potato, and it's an SDL application running on Linux Debian headless version, which means it is basically just a big console. And well, while the application did show up, I couldn't get the keyboard inputs to, well, be recognized by the SDL application. After weeks and weeks of trying to figure it out, I finally made a video yesterday on asking the Linux folks on what could be a possible solution to this. A lot of people have suggested to install a desktop environment, a simple one, much simpler than the one I was running, or try to run a window manager, some sort of a custom window manager like OpenBox. I haven't tried any of those solutions yet. I think I've looked into OpenBox before and I failed to install it, to set it up, but who knows, maybe I'll give it another try and maybe this time it'll work. But I found a solution that gets the job done without needing any desktop environments or window managers. I spent a good amount of time in a video complaining how Linux is supposed to be this universal, super easy to work with, super straightforward to handle operating system, and you can just talk to any piece of hardware by addressing a file on a hard drive. And right after I published that video, I actually got to thinking, is there such a thing as just Python talking to a file? Apparently, yeah, there is such a thing. Apparently, you can quite literally get yourself into the, the dev input directory, and then there you go. You've got event 0, event 1, event 2, mice, mouse 0. These are the literal input files that handle any sort of input device. As a matter of fact, if I were to disconnect the, the mouse, the USB mouse that I have connected here, and run this again, we got 2 less devices. Nice. So event 1, by the looks of it, is for the keyboard, because that's the only input device that I have connected. What do you know? There's a Python library specifically meant for addressing these input devices. And it is called evdev. This library is quite literally meant for addressing your input devices. It's got all the shebang that I needed for this project. We've got reading events that allows you to I have to actually run this in a separate thread because it's technically an infinite loop, and SDL also starts its own loop to handle the graphical user stuff. So you can filter out the events by type. You get the key type. We have the mouse type. We got all sorts of other interesting events. We can check what are the currently actively pressed keys, so I can check for things like if Shift is pressed, if Control is pressed, all these modifier keys. You can get yourself all of this information per each event, like the time when the event has occurred, the type of event. Here's the key code, and then the value allows you to specify if to check if this was a button down or button up or button hold event, the timestamp. Everything I needed was right there, right under my nose. I think I just had to make a video about it. I just had to make a video where I bitch about me not being able to figure it out, and then I guess during that video I asked the correct questions that forced me to do the correct search queries, and I finally found the answer. Check this out. So, if I'm just gonna... what do we need to do? Python. This is input test .py. Yeah, nice. First try. And yep. Okay, we're gonna have to hide the cursor, but as you can see, all of our inputs are being processed. Even if I hold shift, place a little bit of code modify the capitals. Now, spaces are actually literally inserted as spaces, and this is kind of the limitation of the library. See, this particular library deals directly with scan codes. So you have a particular key ID that is assigned to each and every key, and the library does have a set of predefined constants that it can use to convert the key code into the predefined constant, but it would be like key underscore space or key underscore enter. It doesn't work with like ASCII character sets. I tried converting it. It does not map correctly to it. So I'm gonna probably have to do a whole bunch of conversion unless there is something else that I can use to convert key codes into regular letters, including like capitals and lowercases. But this library doesn't really discern between capitals and lowercases. It just knows if I am pressing shift, but it doesn't understand that if I hold shift and F, then I should get a capital F. It just sees, oh, the shift key is pressed and the F key are pressed. Cool. You do with that information whatever you want. Which, you know what? It's not as flexible and it's not as convenient as SDL's inputs, because SDL literally has a dedicated function for retrieving the current typed in string. Like, you can literally type for a good 20 seconds and then run that command, and that SDL command will give you the string version of what has been typed up, special characters, capitals, lower cases, anything. It's all going to be there, automatically converted for you. This is a bit more raw, but it works, and that's all that I care about. It works. It's probably not going to be multi-platform. It doesn't have to be. It just needs to run on these Linux computers. That is perfectly fine. Yes, it would have to be Linux only, specifically because it has to address the evdev. It has to address the dev input folder, which is Linux specific, but hey, at least I got it working. However, while I was trying to figure out this little issue, trying to figure out how to get this library to actually run, I ran into another annoying thing, this time pertaining to SDL itself. Not to worry, I figured everything out, everything is fine, but alas, it gave me sass and a huge pain in my ass, but I digress. So the sole fact that the keyboard events or the print commands are actually appearing while the application is running is telling me that the application is receiving inputs. It is capable to actually read them because I had nothing. Literally, SDL was giving me nothing. It works. Yes! Okay, I can start migrating this solution to the actual text-based adventure game, and cool. That's gonna be a huge bonus. I can actually make the keyboard module, because as I said, right now this keyboard module isn't actually a keyboard. It's just multiplexes all of these buttons, and then it's my job to convert the button presses to actual keystrokes, which aren't really keystrokes. It's just there's a dictionary of letters. And it maps each button to that letter, so you can use this in the Python application, but you can't use this in the actual operating system. So this means that I can actually, not have to do this, and I can base it on, let's say, like an Arduino Leonardo, which can emulate a keyboard, which means that you would be able to use this keyboard both in the application and in the operating system. And I think that's a huge bonus. But I noted something really weird. There seems to be a difference between running the application and running this particular input test. And I kept getting crashes, like it just wouldn't load, wouldn't create the resource, the surface with all the text drawn to it, and I did not understand why. It was such a mind-boggling problem, because I launched the main application and it works, but then I launch this input test application and it crashes. I look at the two codes and they're literally the same. Why does this one work and this one crashes? And I think I've boiled it down to the fact that The environment, apparently now I have to set up an environment. I can't just install the libraries on the system level because for some reason Debian complains about it, and I have to make a new Python environment and then install the libraries into that environment and then run the application from that environment. Apparently, when you create an environment, all of the paths are then local to that environment, not local to the Python file that is being executed. Which explains why when I run the main application, the environment was created in the main application, relative to the main application. But then into that application folder, I put a subfolder for the test. And because the environment is relative to the main application, not the subfolder, all of the paths for textures, for font files, for images, for any sort of sprites and effects, all of the paths are borked. They're all messed up. So for example, just for comparison, here I have the setup function, and then you can see I'm saying, okay, we're going to open up a file. It is located in game data, and then the file is the game data.json. There's nothing in front of it, which normally causes the Python to essentially open up the folder relative to its own location. You can see that if I go to the directory on the Libre computer, there's the engine folder, and then I have game data. So this is the lt.py file. This is the Lonesome Trail Python. There it is. So we go to the game data right there. So that's this folder right here. And then it goes into game data.json, which is this one right here. Cool. It works. If you have any subfolders with little experimentational files, no, you can't use relative file locations. You have to do this. You have to do this nonsense, which is first you have to import the operating system library, the OS library, and then you have to use the OS path joining operation, take the directory, the current location of the directory, which of course we have requested here, right? OS, get the path of the file that is currently being executed. That becomes our base directory, and then we have to use an operating system joining command to join this path and the relative path, and we still have to encode it because we're not allowed to do things the easy way. We have to always go through these little hurdles. So in a nutshell, it basically says, cool, yeah, let's make sure that this is the directory. This folder is the directory, and then from here we can go into game data, fonts, VT323, and then load the TrueType font file. From this point on, I suppose I should just get used to requesting the root directory and then joining all the paths. Fine. All right, I'll work with that. But the problem is that it took a little too long to figure out. That problem wasn't very apparent because here's the wild thing. This is how mind-numbingly annoying this was to actually figure out. So this entire routine creates a surface based on some text. And it converts that surface to a texture so that we can display it. We use the render copy to, well, render that texture to the screen. And then we destroy the texture and then we destroy the surface. Cool. Well, here's the only thing. Go ahead and roll back the fix of making the font relative to the file explicitly. Here we go. So we're going to make it as it was before, as it's in the main project, not in this test. There we go. So this is what we have. We have our font, 24 pixel font. It opens the file called game data fonts VT323, VT323 regular.ttf. We encode the path, and then we set the size of the font to be 24 pixels. Okay, what happens when we take this and we print this sucker? Okay, so we're going to do this. All right, there we go. Pull up the file, and there we go. Okay, so it says explicitly, you see that underlined command, txtsurf.contents.w, null pointer access. Null pointer access. But, okay, well, what the shit does that mean? Null pointer access. So it's either failing to find this, or it's failing to find this. One of these two. Or the width property. Well, why don't we take a look at which one it is? All right, let's go over here where it's right before it's crashing. Let's print. What are we printing? So it's trying to print this thing. Okay, I'm just gonna do this. We're gonna print the surface. Now we're gonna print the surface contents, and then we're gonna print surface contents W. We got 3 print commands. All right, and then you know what? Just for good measure, there we go. Perfect. Save it. Drag the file over to the computer through SSH. Launch. And okay. So clearly, it's complaining about this being a null pointer. TextSurf contents is a null pointer. Is it though? Well, okay. So this right here, that's what's that. Apparently, this does not exist. But does it though? Let's print. We're gonna do this. We're gonna print ourselves the list of properties and member methods of this resource, right? Clearly this exists because it didn't crash on this. It tells us that it exists right here, so we know that's good. Okay, let's save it. Let's drag that sucker over. Let's launch it. And okay, here's the list of properties. What the fuck is this? What is this? Contents. And then it says contents is a null pointer. But it's right there. But it doesn't exist. But yes, it does. But no, it doesn't. Ugh. Issue was such a pain in the ass to debug. And only after like a couple of hours, I finally came across a command that explicitly gives you any sort of errors specifically caused by the TTF library of SDL. Because apparently it's a standalone, self-sufficient library that has its own error processing. So unless you know about that, it won't fail creating the surface, it won't fail creating the texture, it won't fail showing you what properties there are, but it will fail when you actually try to access those properties. I would imagine that if it fails to create a surface, it would return null, as the documentation explains that it should. But it doesn't. So the only way to really find out what the hell's happening is to essentially run a command after every TTF line you have in place. So for example, I'll do print error. Let's do TTF error. And then we're going to print, what is it? TTF get error. That's the command. You have to explicitly run it in order to get the TTF error. And you know what? I'm going to put /r/r for a couple of empty lines before. And then we're also going to do that over here. All right. Drag and drop the file over to SSH. And go ahead and run it. And there. TTF error passed a null pointer. Okay, but what in here was passed as a null pointer? Final text is right here, being declared. We encoded. I'm pretty sure it's not a null pointer. The only other thing that we pass along, right? We got all these integers, everything is fine. Either this, but we explicitly create it here, or this. Okay, well maybe that's the null pointer then. Okay, well let's double check if it's a null pointer. Print. We're going to print font24 and the actual variable. Let's drag and drop and then get it up and running. Is the font file a null pointer? Where is it? No, it fucking isn't. Look at that. Font24, SDL2, font object. Does this look like a null pointer to you? Huh? So, I print it. It doesn't say it's a null pointer. But when I try to use it, it complains that it's a null pointer. Swear to God, it was... I got really lucky that I actually came across a Stack Overflow question on the subject, and somebody had specifically mentioned that they fixed it by making the path relative. It was a fluke that I actually came across that answer, because how would anybody know? How would I be able to tell? It's supposed to return a null pointer if it's an incorrectly loaded file. That's how I know that it failed to load. But it's like, nope, everything's totally fine. Yeah, that looks like you tried to use. Well, nope. So now, of course, we know that this is a global variable, so we know that it's referenced from the outside of the function. We go back up right here, and then we make it. We have to make it relative to the path. So we got to do, what is it? os.path.join, and then we're joining the source folder location, the location of this file. We're joining it with the relative folder, with the relative path to the font file, and then we encode this motherfucker because apparently it doesn't like it, and then we print it. We print it right here. God damn it! We printed it right here, right after we loaded it, and then you can see right there. It was a valid font resource, font object. That should be null. That should be failing. That is bullshit. But anyways, we fixed it up. OS path join. I will upload. I will push. And then finally, oh look, it works. I knew what I was signing up for. Because this is Linux development. This is working with an SDL, which is a C library that I'm communicating through Python bindings. We are making progress, but little bits and pieces like that crop up and they kind of drive me nuts. But yeah, silver lining. We now know what's up. Work with any sort of paths. We have to explicitly get the path to this file, and then all the relative paths have to be joined to that path using OS path functions. We now know we have to do that. That is just something we'll have to keep in mind. And don't trust the SDL library to accurately portray the source of the issue, especially when we use TrueType sub-library for SDL. We're just going to have to explicitly use TTF get error in order to see if it actually experienced an error. Whoa. Okay, let's see if we can actually get text inputs into the mainline application now. So, with that out of the way, what are going to be the next steps for me setting up this project? Well, of course, first of all, I need to get a proper keyboard. So, I'm going to be redesigning this little keyboard right here, except instead of these little clicky buttons, I'm going to be using these bad boys right here, which these buttons feel really nice. They got a nice rugged spring feel to them. They don't have a click, but you know what? That is okay. And essentially, this is going to be kind of like the mimicry of an old school mechanical keyboard. It's a nice little momentary switch. We're gonna have a little 3D printed keycaps. I got an Elegoo Mars printer specifically to try to get very fine, detailed 3D prints. So we're gonna see about putting together some keycaps. Trying to keep the keyboard around 2 thumb range so that it doesn't get as atrocious as this little behemoth. Like this is not exactly comfortable at this point. So yeah, trying to keep it down. These keycaps are kind of big. The keyboard itself is gonna be actually emulating a keyboard this time, just like I did on this one. So it's running on a nice. Come on, focus, you bitch. It's going to be running on an Arduino Leonardo. We're going to see about just obscuring this a little bit. This was technically used as a mouse, but I think I'm going to try to mess around with some other type of joystick interface. Take a little bit of time to get the keyboard printed and sent in the mail from JLC PCB. So in the meantime, I think we can take care of restoring the Nixie display. This was highly experimental. These driver chips, I liked working with them, but god damn, is it easy to destroy them. I think I might have just overheated them because of my shoddy, well, solder work, if you can call it that. Yeah, I tried to desolder them and resolder them. I think at some point it just overheated these chips and they bit the dust. So you know what? What I figured is let's go the simple route this time. Instead of relying on these driver chips, why don't we just go with a big old fuck bag of BJTs? Some high voltage BJTs. I got this entire bag, I think contains around what? 1,000 transistors. And it cost me a whopping total of about $100. I'd say that's pretty damn affordable. And of course, in order to drive these, we're going to be using some good old shift registers. Yeah. You can tell I went a little trigger happy on the credit card purchases, but then again, you can never have too many of the old reliable 74HC595. Yeah, nice. So that's gonna be my next step, getting the Nixie displays up and running. And folks, these displays are highly demanded. I see these get snatched up very quickly on the Nixie Facebook groups that I'm frequenting, which is the reason why eventually, once I settle down, set up a little shop, I really want to try experimenting with making my own Nixies, following the footsteps of Dalibor Farney and that Asian gentleman who's also been making some decorative Nixies. But I just wanted to make some myself. It's fairly straightforward in principle. Never mind the fusion pump costing about $2,000, but shh, don't tell anyone. My general goal, right now I'm just dreaming, but my general goal would be to just experiment with it. Have fun. And if this text-based adventure game actually sees the light of day, then being able to produce my own Nixies means that I don't have to depend on new old stock and the increasingly rising prices of these beautiful, beautiful Nixies. God, that amber glow. Man, just look at that beautiful amber glow. I would hate for this technology to just be lost to the times, let alone to become inaccessible or, well, financially prohibitively expensive for me to use in my projects. God, that's such cool tech. Now, don't be fooled by my careless handling of close to 200 volts there. I have, unfortunately, lost a number of these Nixie driver power supplies to loose clips and accidental grounding. So, yeah, I only have one last power supply that I can work with. So I have ordered a bunch of parts to see if I can put together my own little switching step-up converters. 12 volts to what do we get? 12 volts to 120. It is regulated, as far as I know. So, yes, I know that you can find more of these power supplies. They're about $16 a pop, but I really want to learn how to be more self-reliant and to be able to put together my own if I really need to. All right, so good progress. I'd say we've made pretty significant strides, and we have finally burst through that brick wall, that dead end. We've dug our way around it. So, progress continues.